Hello all. Today we start a discussion on transportation problem. Transportation problems are an essential component of subject like operation research. So what basically are transportation problems? Transportation problems are problems wherein we try to assign combinations. Combinations wherein we'll be transporting from our sources, let me call them sources, or I could call them maybe my factories. From sources or factories, I'll be transporting goods to destinations or maybe my markets where I wish to sell. So in a brief example, let us say I have three sources or factories A, B and C from where I wish to transport goods to market 1 and 2. Suppose I produce 10 units at A, 15 units at B and maybe 25 units at C. So in all, I'm producing 10 and 15, 25 and 25, 50 units. I'm producing 50 units and maybe my markets have a demand of 20 units and 30 units respectively, thereby constituting a demand of 50 units. So this looks like a very well balanced transportation problem. This is a balanced transportation problem. Now, what this matrix is telling me that I have three sources or factories A, B and C with their respective capacities of 10, 15 and 25. Then there are two destinations or markets with the demands of 20 and 30. Now, suppose I transport a unit, one unit. I transport one unit from A to first market. I'll be transporting a unit from A to first market. Now, if I transport one unit from A to first market, let's say it costs me 2 rupees. If I transport that very same unit from A to second market, maybe it costs me 8 rupees. Similarly, let us say we have a 4, 6, 9 and 7. Now, what is happening is these are various cell combinations telling me what happens if I transport a unit from respective market factory to a particular market. Let's say this is cell C second. So this is telling me that it will cost me 7 rupees if I try to transport a unit from C to second. Okay. So this is basic organization of a transportation problem wherein we have rows and columns. We have loads available for rows. We have loads available for columns. Before we could begin, we should check that these loads should be balanced. If it is so, then we can go ahead and try to make proper assignments. Assignments that will be optimal. Assignments that will be trying to minimize the total cost of transportation. I need to transport my 50 units to my 50, a demand of 50. Now I need to accomplish this combination at minimum cost. That is what we'll try to do in these transportation problems. Now, how do we approach these transportation problems? It is a two-phase process. We will not try to solve these transportation problems in one go. We'll solve them in two phases. First phase being, we'll find out IBFS for the given problem. IBFS is initial basic feasible solution. So as the name suggests, it is very initial solution, very preliminary, very first initial solution. Basic, it is a starter solution. It may not be a very good solution, it may not be a very optimal solution, but it is a basic solution. It is a solution that will transport all my 50 units to my markets where they are needed. How they do it, at what cost they do it, I'm least interested about that in at least in first phase. So it is initial, basic. Feasible, why feasible? Because this will be a solution that will transport all my 50 units to the sources where those 50 units are needed. But I cannot guarantee that it will be optimal or not. I will be able to transport my 50 units where they are needed. I'm not sure if it will be best or not, but it will definitely be feasible. Feasible in the sense that A will be able to transfer all of its 10 units. B will be able to sell all of its 15 units. C should be able to sell all of its 25 units. And what about markets? Market A should get a supply of 20, while market 2 should get a supply of 30. So this is what I'll be able to do when I'm done with feasible solution. So my solution will be initial, basic, feasible solution. So this would be our phase 1. Now, when you solve transportation problems and you are through with phase 1, it is not at all necessary that the solutions of two students will be similar. They can be different. Their total costs can be different after phase 1 because it is only an initial solution. Depending on the choices you make, you might end up with different solutions. But once we are through with second phase is optimization. Once we are through with this optimization phase, optimization is wherein we try to improve upon the solutions. We found out a starting point. We had a solution which was basic, which was initial, which was very raw in nature. Now we'll be improving upon it. It is a bit like here we learn to walk. At least we should know how to walk. Then only can we run. And maybe run 100 meters in record time. So it is not possible to run 100 meters in record time if we do not know how to walk. So what we'll try and learn is, first we'll try to walk in IBFS and then we'll try to optimize, that is run at a brisk pace. So phase 1 would be an initial solution phase and phase 2 will be an optimization phase. So once we are through with these two phases, we'll have a transportation solution that will be best according to the known algorithms. Now, what are the methods that we can learn or apply? For phase 1, that is IBFS. For IBFS, we will learn 3 methods. First one would be NWCM, Northwest Corner Method. As the name suggests, Northwest Corner Method. Probably it will be having something to do with north and west corner. We'll see what this is about when we get there. So first one would be northwest corner method. Second method that we'll learn would be LCM, that is least cost method. And finally, for IBFS, the best method, a method that 6, 7, 8 times out of 10 will give you the best possible solution in first go. It is Vogel's approximation method. So these are three methods that we'll learn for IPFS, initial solution. Once we are through with these initial solutions, we'll move to second phase. Second phase is that of optimizing the problem, optimizing the solution, optimizing our assignment, optimizing the solution. For this, we'll be making use of two methods. We could use either one. We'll learn these two methods. First one would be a stepping stone method. And then we'll learn another method which is called modified distribution. These are the two methods that we'll use for optimizing our solution. So this was a basic introduction about what a transportation problem is, how it looks like. Next time when we meet, we'll try to solve this kind of transportation problem. We'll try to make assignments in these problems, assign various loads. That we'll see when we get there. For now, thanks for watching. Don't forget to subscribe to the channel for latest updates. Bye-bye. Thank you for watching.